6.6 function operations. This is actually going to be part 1. We're going to split this up into 2 parts. So this is going to be part 1. So function of operations, when we have addition, subtraction, multiplication, division. Now when we're doing this, we're going to be focusing on the domain and range. So actually more on just the domain. So domain is your input, range is your output. But a lot of times right here, this is domain, because when you're looking at fractions, you cannot have 0 on the bottom of a fraction. The other thing you have to be careful about when you're talking about domains are radicals. So if you look down here, this is radical, because you cannot take the square root of a negative. So we know that we can when we use imaginary numbers. However, when we're doing domain, we're talking about real numbers. We're not thinking about 3D coordinate. We're thinking about a 2D coordinate. So the first section, when we're adding and subtracting. Now these are pretty straightforward. This is saying we're adding our two functions together. So here are our two functions. This is the function of f, this is the function of g. And those functions right there just to basically name it. Just like how we have different names. We have Mrs. Sharper and we have Mrs. Frickman. We're different people, different functions. The same type of thing. Now when you're adding, this addition is not going to change anything in my function. So I would have my function of f, so it's going to be 4x plus 7 plus my function of g, which is square root of x plus x. Now these two are both like terms, not that one, this one. So we can combine those two like terms. So my final answer would be 5x plus 7 plus the square root of x. Now I'm talking about my domain here. So if I'm looking at my domain, this is where I have to be careful. So if it was just the 5x plus 7, we would say all real numbers because it doesn't matter what x would be. However, since we have the square root, we cannot take the square root of a negative. So my domain here would be x has to be greater than or equal to 0. Because if we have x is equal to 0, we can take the square root of 0. Sure we can, but we can't take the square root of a negative. So that would be the first one. Now it's asking for subtraction. So when I'm doing subtraction, again, this is not where you have to be careful because this subtraction is basically saying the opposite of the function. That's what subtraction is, opposite of a function. When I write out my problem, my function of f is 4x plus 7 subtract. I'm going to put this in parentheses now. The square root x plus x. You have to remember to distribute the opposite to both terms in here. So I have the 4x plus 7 and then distribute my opposite. And now again, I still have my two like terms right here. So it would be 4x minus x would give me 3x plus 7 minus the square root of x. When I'm looking at my domain, again, what numbers x can be, again, we still have that square root. We still cannot take the square root of a negative number, so x still has to be greater than or equal to 0. You should try to do the second one by yourself. Do the second one by yourself. So now here we have multiplying and dividing. So first we're doing multiplication. So when you're multiplying, if I write this out, I'm going to make sure to put this in parentheses. So my function of f would be x squared minus 9 times my function of g, x plus 3. Now when you see this, you have to FOIL. First, outside, inside, last. So if I FOIL this out, I would get this, and I look, there's no like terms, so that would just be multiplying together. Now I'm looking at my domain. What can x not equal? So in this case, x can equal anything here. It does not matter what x would be because there's going to be no undefined. So meaning we don't have any square roots and we do not have any fractions. Those are the two things you always have to be careful about. So my domain here would be all real numbers, or else you can put all real numbers, or you could say negative infinity to infinity. Now my division here, so my division, my function of f, so x squared minus 9 over x plus 3. Now actually, I can simplify this. Because if you can, you should try to factor. And I can factor the x squared minus 9. Because there are two numbers that multiply to get negative 9, but add to get 0. So I have my x plus 3 and x minus 3. Those two together multiply to get x squared minus 9. And then I have my x plus 3 on bottom. Now this is where you have to be careful. When you are simplifying, you have to state your domain before you simplify. So before I actually simplify this, which I can, I'm going to write over here my domain. Now if I look, when I'm dealing with division, I create a fraction bar because you cannot divide by 0. So this right here cannot be 0. So if that was 0, that would be no good. So I would write over here x plus 3 cannot equal 0 because bottom can't equal 0. And then you solve for x. So in this case, my domain would be x cannot equal negative 3. It can be any number but negative 3. Now I want to go back and simplify my fraction. Now because this is multiplying in between here, you can simplify it multiplying, and these are in parentheses. I can cancel out this whole thing with this whole thing. Again, you can only cancel if it's multiplying. Only cancel if it's multiplying. So the only thing I have left here is my x minus 3. So my answer would be x minus 3, but x cannot equal negative 3. Because even though we got rid of the division, it was there first. So you should try to do the bottom one and making sure that you factor this. You should be able to factor this when you are simplifying. And letter C. So if I look at this right here, this is basically exactly what it's saying. It's saying 4 times my function of f, subtract 2 times my function of g. So again, it's 4 times my function of f, so I write my whole function of f here, minus 2 times my function of g. Exactly what's written for my function of g. And now it just becomes an algebraic problem or pre-algebra problem. So you have to distribute your 4, distribute your opposite 2, so a negative 2. And now you should look to see if you have any like terms. Here I have an x, here I have an x, here I have a number, here I have a number. So my final answer would be 12x squared. Negative 44 minus 6 would give me a negative 50x. Negative 16 minus 2 would give me negative 18. Again, now I'm looking at my domain. When I'm looking at this domain, there are no values that x cannot be because I don't have a fraction here, and I do not have any roots. Those are the two things that we're focusing for this chapter. Later on, we're going to get into more difficult stuff, but that's what we're focusing on first. So again, either all real numbers. If you want to look again, you draw 2 lines. You start at the line you drew first, and then make an R. That's all real numbers. And that right there is all we're doing for part 1 for 6.6 functions. Have a great, grand, wonderful day.